Recording in progress.
I will tell you, inshallah. Okay. Yeah, for this, he has applied brakes, and you need to tell the distance time graph for this. Yes.
So the distance covered, like after T1, will be increasing.
So what is the correct option?
I think it's B.
Delta option.
What?
What you are saying, the second option or the last option?
The second option.
No, it can't be B.
I don't think it's A.
Yeah, it is not A.
So how is it not B?
Because you see, they have given you this
Oh,
steep line like this. But this can't be, this is a sharp line, we don't get line like this. When you put this velocity time graph over this, so you always have a graph like this. What is happening with
okay.
this? Okay, like this. Again, same. Oh God. Okay. So which graph would be the right option?
So it's, but like, if
Hmm.
the distance covered it increases,
Hmm. Firstly, there will be
shouldn't it
more
be like,
steepness. Then the steepness will decrease because he has applied brakes.
oh, okay.
So
So it's C.
yes. Okay. Wow. Why is this happening on this file? Okay, let us see. An object falls 10 meter from the rest before entering some water, assuming negligible air resistance. What is the time taken to reach the water and the speed with which the object reaches the water? Falls 10 meter from the rest. Okay, initially it was at rest. The object was at rest before entering some water. And now they've mentioned that the air resistance is negligible. What will be the speed and time taken? How you will solve it? Which equation you will use to calculate the time and the speed?
Wait, an object was. So there's no air resistance in this one.
No air resistance.
It falls from rest, so the initial velocity is 0.
Yeah, initial velocity is zero. So which equation we can use?
You can use the
Hmm.
S equals 1 over 2 AT squared.
1 over 2 AT square. S equals, so you will have half. What is A?
Is 9.81.
And S is, what is S? S is 10. That is 9.8 and T square. So you will have
Yeah.
2 into 10 divided by 9.8 into T square. Okay, solve this. It will be 20 into 2 into under root 2 will be, I think it will be 1 point, under root 2 will be 1.4 or 1.5 maybe.
It's
Hmm.
it's 1.4.
Yeah, it's 1.4. Okay. And then when you have time, now you need to calculate the speed. Which formula we will use?
Speed equals this is better.
Yes, simple. Distance divided by time. Distance is 10 and time is 1.4. So you can solve it.
It's
Sorry, this is
7.1.
this is wrong. S equals V over T. So you will multiply
What?
S and T. This is the formula.
Okay. Oh yeah. Okay.
So S into T, 10 into 1.4, that will be 14, right?
Yeah.
So the option will be D. Clear?
Yeah.
Okay. Which features of a graph allows acceleration to be determined? Acceleration. Okay. The area of displacement time graph. What we get from the area of displacement time graph?
The area of displacement time graph.
Mm-hmm.
Um.
Hmm.
Wait. There's nothing under the displacement time graph.
Displacement time graph. Okay. Then the area under velocity time graph.
It gives you displacement.
No. Area. Okay. Area of velocity time graph. Now we will get displacement. Okay. Next.
Yeah. Slope of displacement time graph gives you acceleration and velocity.
Slope of displacement
It's
time graph.
D.
Yeah, it gives you velocity. Slope of velocity time graph gives you acceleration. Yes.
Yeah.
Okay. And a boy throws a ball vertically upward. It rises to a maximum height where it is momentarily at rest and falls back to his hands. Which of the following gives the acceleration of the ball at various stages in its motion? What they are saying? A boy throws a ball vertically upward. So firstly, the motion will be vertically upward. It rises to a maximum height. So vertically upward. Now it is at the maximum height and where it is momentarily at rest. It will be at rest at this position and fall back to his hands. Now it will fall back to his hands again. Okay.
Okay.
So which of the
So
following is the acceleration of the ball at various stages? What will be the acceleration at various stages?
when it's rising means when it's thrown upwards.
Hmm.
It's it's positive 9.81.
Okay. Then
And then at maximum height it's 0.
okay. Then
And when it's falling it's minus 9.81.
didn't we discuss it
It's
that the acceleration when there is negligible air resistance, acceleration in that case would be negative 9.81 meter per second square, isn't it?
yeah, but yeah, when it's falling.
No, I told you that even though when the ball is moving upward, the gravity is pulling it down, right? To slow it
Yeah.
down. This is the concept I told you that even though when the ball is moving upward, the gravitational force is acting on it downward in the downward direction. That is negative g. That is negative 9.8 meter per second square. And when it is at the maximum height, it has 9.81 meter per second. And that is also negative because the weight is acting downward. The weight is acting downward, meter per second square.
Okay.
And when it falls down, again, it will be minus 9.81 meter per second square. This we have done when I was telling you the graphs, when we were discussing the graphs, different graphs. That
So
even though,
downwards,
hmm,
but what if you make your like own convention?
no, we are saying because the weight is acting downward. The weight is acting downward. On that
Mm,
basis, we are saying it. Even though when you throw the ball against the gravity, but its weight is acting downward, isn't it?
yeah.
And when it
So
is
when
at
it's
maximum
falling,
height,
it will still be negative, or
yeah, it will still be negative because weight is acting downward.
but what about at maximum height?
That is also because if you see at maximum height, can that body stay at maximum height? It will definitely come
No.
back to Earth. That is why its
Yeah.
weight is acting downward. That is why it will have minus 9.81 meter per second squares gravitational acceleration at that moment as well. This is a very
Okay.
important concept. At maximum height, they have mentioned at that where it is momentarily at rest. Although it will be momentarily, what is meant by momentarily at rest? That for one moment it will be at rest. It can be at rest just for 1 second or for a minor second, for a microsecond maybe, but it will come back to the earth and it will fall back. So when the ball is falling back, it means it has acceleration. It has gravitational acceleration that is pulling it downward. Okay.
So the answer
If
is
we say if like if the acceleration were zero, the ball would remain suspended in the air. The ball is not suspended in the air.
yeah,
It comes back.
it
That's
comes
why
down.
acceleration is minus 9.1.
Okay,
9.81. Are
so
you
it's
clear?
B.
Yeah, it's B.
Yeah.
Throughout, it will be minus 9.81 meter per second.
Okay.
Okay. A projectile is launched at point O and follows a path OPQRS. Air resistance may be neglected. Which statement is true for the projectile motion of this body when it is at highest point Q?
Um, and when it's the highest point Q,
Hmm.
the
We have discussed it
so
earlier. What is the horizontal component at highest point and vertical component?
the the horizontal component is the same.
Hmm. Horizontal
The
component.
vertical component is 0.
Horizontal component of projectile acceleration is what? What?
0.
Zero. So this is your answer.
Okay, it's A.
Okay. Yeah, this is the repeated question, I think so. This was, I think,
Yeah.
we have done in the very beginning. Okay. Following is the velocity time curve, which what is the distance traveled between time t and time zero? Time zero and time four.
The distance between time 0 and time 4.
Hmm.
So it's the area under the graph.
Hmm. Area under the graph.
2 times 4 plus. Wait, I'll do it once.
Okay.
Oh no.
Because you have two things. Over here you have two
Yeah.
things. This one, this triangle, and this little rectangle. So it will be half into 12 into
28, I think.
12 plus 2 into 4, 10 into 4, that will be 20. And over here you have 2 into 4 is 8. 8, so 20 plus 8. It will be 28. What's your answer? Hmm?
Sorry.
Are you there? Hmm?
I got 28.
Yeah, 28 meters per second. A football is dropped from the top of a tall building, which acceleration time graph best represent the motion of the football through the air.
Through the air. Um, they didn't say anything about air resistance.
Yeah, they didn't mention about it. So it means there will be air resistance through the air. They have mentioned through the air. It means there is air resistance present.
Okay, so it's C.
Yes. You see, most of the questions are repeated in the same manner. You will get just few which will be hard, and you need to practice them most of the time. How you can practice them? You can change values, you can change scenarios, and then solve them. Or you can ask ChatGPT by putting that question and ask the ChatGPT to generate questions like that. Okay. A car driver sharply presses down the acceleration When the traffic lights go green, the resultant horizontal force acting on the car varies with time as shown, which graph shows the variation with time of the speed of the car. This they have mentioned over here if you see. Force into time. A car driver sharply presses down the accelerator when the traffic light go green. You know the accelerator that is used to increase the speed. Just like the brakes, there is accelerator as well.
Yeah, there's accelerator.
So they are saying the car driver presses accelerated, and that due to pressing that accelerator, its
This
speed increases, right? The resultant horizontal force acting on the car varies with time as shown. Hmm, बड़ा किस time की light रहेगी यार.